Hello everyone, my name is Santosh and I am a student of BSc Chemistry Honors first year. Here is an audio video lecture on some of the important points which we use in chemistry, and these are as first is the law of conservation of mass. Law of conservation of mass deals with the mass of reactants and products and states that in a chemical chain the total mass of the product is equals to the total mass of the reactants. Law of constant composition. Chemical compound always contains same elements combined together in same portion by mass. Law of multiple proportion. When two elements combine to form two or more compounds, then the mass of one of which combines with the fixed mass of the other element bears a simple whole number ratio to one another. The average mass of various elements are determined by multiplying the atomic mass of each isotope by its fractional abundance and adding the value thus obtained. 1 mole of atom is equals to 6.022 into 10 raised to power 23 atoms, that is GAM of element. 1 mole of molecule is equals to 6.022 into 10 raised to power 23 molecules, that is GMM of substance. Number of atoms or molecules in a given weight of an element or a compound is equals to the weight of the substance into Na per gram. Atomic weight or gram molecular weight. Molarity. Number of moles of the solute per liter of the solution, that is M is equals to WIM into 1000 upon volume of solution in liter. Equivalent weight of element is equals to atomic weight upon valency. Atom is made up of small particles, that the three fundamental particles called electron, proton and neutron discarded the indivisible nature of the atom proposed by John Dalton. J.J. Thomson, the discoverer of electron, proposed in 1898, in which he assumed an atom to consist of a uniform sphere of positive electricity with electrons embedded into it in such a way that it gives the most stable electrostatic arrangement model known as the plum pudding. Rutherford nuclear model of atom was given by projecting alpha particles which have very high energy. Drawbacks of Rutherford model is due to the fact that it can't explain the atomic model according to the classical electromagnetic theory. Maxwell suggested that the radiant energy, the energy which is radiated such as heat, light, X-rays, etc., travel in space with the velocity of light, that is 3 into 10 raised to power 8 meter per second, in the form of waves known as electromagnetic waves, that is EM waves. E is equals to h nu, where h is the Planck's constant and its value is equals to 6.6 into 10 raised to power minus 34 joule second, or 6.6 into 10 raised to power minus 27 ergs. This phenomena of ejection of electrons from the surface of a metal when light of suitable frequency strikes on it is called photoelectric effect. The emitted electrons are called the photoelectrons. The number of electrons ejected is proportional to the intensity or the brightness of the light striking the metal but do not depend upon the frequency of light. Electron can revolve only in those orbits whose angular momentum is an integral multiple of h upon 2 pi, that is mvr is equals to nh upon 2 pi. When energy is applied, the electron moves to the higher energy shells depending on the amount of energy absorbed. When it comes back, it emits the energy. Electron comes back from the energy level having energy E2 to energy level having energy E1. Then energy of emitted radiation is given by E is equals to E2 minus E1, that is equals to h nu. Light possesses both wave and the particle character, that is dual nature. De Broglie proposed that just like light, all the matter should exhibit both the particle and the wave-like properties, that is the dual behavior. Heisenberg uncertainty principle states that the position and the momentum of the microscopic movement particles cannot be determined simultaneously with accuracy or certainty. Principal quantum number n, it has integral value of 1, 2, 3, 4, etc., also denoted as the KLMN shells. Azimuthal quantum number L tells us about the sub-energy shell of the electron. For each value of n, L can have the value from 0 to n minus 1. Magnetic quantum number M explains the behavior of an electron in the external magnetic field. The value of M gives the number of orbitals associated with the particle subshell in shell. For each value of L, M can have values from minus L to plus L, including 0. Spin quantum number S gives an idea about the electron spinning on its axis. Each spinning electron can have two values of plus 1 by 2, that is clockwise spin, and minus 1 by 2, that is anticlockwise spin. Aufbau principle. It states that the electrons are filled in the orbitals in order of increasing energy. The energy of the orbitals in order of increasing energy. The energy of orbitals is governed by n plus L rule. In simple words, orbitals of lower energy are filled first, followed by the orbitals of the higher energy. Pauli exclusion principle. It states that no two electrons can have the same value of the 4 quantum number. This implies that no two electrons are alike in an atom, or in other words, an orbital can accommodate a maximum of 2 electrons. Hund's rule. This rule states that the pairing of the electrons in degenerate orbitals belonging to a particular subshell, that is p, d, or f, does not take place till each orbital occupied by a single electron with the parallel spin. Number of radial nodes is equals to n minus L minus 1. Number of angular nodes is equals to 1. So total number of nodes is n minus 1. The shape of d orbital is double dumbbell except the 2z baby Sutar. Dopper grouped elements in traits, that is, for example, lithium, sodium, potassium, or chlorine, bromine, iodine. Newland found that the similar elements are repeated at the 8th place. It happened when elements were arranged in the increasing order of their atomic masses. Mendeleev's periodic table. Mendeleev arranged all the elements in order of their increasing atomic weights. A table which has been formed with the help of the classification of elements is called the periodic table. Modern periodic law given by Moseley. The modern periodic law is stated as the properties of the elements are periodic function of their atomic number. D block elements. D block elements are called transition elements or D block elements. The elements of group 3 to group 12 belongs to this class, and their general electronic configuration is n-1 D10 ns0 to 2. F block elements are inner transition elements. These are arranged in the two rows at the bottom of the periodic table. In the first row, there are 14 elements from atomic number 58 to 71, known as the lanthanoids or rare earth metals elements. The second row of elements from atomic number 90 to 103, known as the actinides. Their general electronic configuration is n-2 F1 to 14, n-1 D0 to 1, and ns2. Atomic radius is defined as the distance from the center of the nucleus up to the center of the outermost electron. It is measured in angstrom unit. The atomic size decreases in a horizontal period as we move from left to right, but atomic radius increases in a group with the rise in the atomic number. Ionization potential energy is defined as the energy required to remove an electron from the outermost orbit of an isolated gaseous atom in its ground state. Screening or the shielding effect. The effect of reduction of force of attraction by the electrons present between the nucleus and the valence electrons is called the screening effect. The order of the screening effect is maximum S, then P, then D, then F. As we go down a group, the ionization energy goes on decreasing along a period. As we go from left to right in the periodic table, the ionization energy will increase. The electron affinity decreases in a group as seen in chlorine, bromine, and iodine. Fluorine has the lower electron affinity than chlorine. Chlorine has the highest electron affinity. Electron gain enthalpy can be defined as the amount of energy associated with the gain of electrons by the isolated gaseous atom. Electronegativity is defined as the tendency of an atom to attract shared pair of electrons towards itself in a molecule. The small atoms attract electrons more strongly than the larger ones, as they are more electronegative. Generally, in a group, electronegativity decreases from top to bottom due to the increase in the size of atom, but for a period, electronegativity increases from left to right. First three elements of second period, that are lithium, beryllium, boron, show the resemblance with the elements of the next higher group of the third period. with diagonally opposite elements, and this is referred as the diagonal relationship. The atomic structure of hydrogen is the most simplest one with only one proton and one electron. It is the element which forms the highest number of compounds amongst all the elements. Water is one of the most important compounds formed by hydrogen. The ionization energy of hydrogen is very high in comparison to the alkali metals, and this is because the 1s electron of hydrogen is tightly held by the nucleus due to its small size. Hydrogen is less reactive as compared to the halogens, and the electron affinity of the hydrogen is less than those of the halogens. Protium and ordinary hydrogen. The predominant form of hydrogen is ordinary hydrogen, protium. It has one proton and no neutron in the nucleus, and one electron revolves around the nucleus. Deuterium. It is also known as the heavy hydrogen. It has one proton and one neutron in the nucleus, around which one electron revolves. Tritium. This isotope of hydrogen is radioactive and emits low energy particles having half-life period of 12.33 years. It has one proton and two neutrons in the nucleus. Laboratory preparation of dihydrogen. In laboratory, dihydrogen is prepared by the reaction of granulated zinc with the dilute HCl or dilute H2SO4. Zinc reacts with the aqueous alkali to give dihydrogen and sodium zincate. Commercial production of dihydrogen can be prepared by the electrolysis of water, electrolysis of aqueous barium hydroxide solution, electrolysis of brine, and by the action of steam on coke. Dihydrogen is quite stable and dissociates from hydrogen atoms only when heated at 5000 Kelvin. Dihydrogen is used in Haber's process in the synthesis of ammonia. A mixture of nitrogen and hydrogen in ratio 1:3 is taken for the production of ammonia. Dihydrogen is used in the fuel cells for the generation of electrical energy. It does not produce pollution, therefore it is advantageous over conventional fuels like gasoline. Electron deficient hydrides. These hydrides have less number of electrons than that of the required for writing the frictional Lewis structure. All the hydrides of group 13 are electron deficient compounds like BH3. Electron precise hydrides. Such compounds having requirement of electrons to write their conventional Lewis structure. The elements of group 14 from such hydrides. The hydrides have tetrahedral geometry, for example CH4. Electron-rich hydrides. Electron-rich hydrides have excess electrons in the form of one or more lone pair of electrons around the central electronegative element formed by the elements of group 15 to 17. The existence of hydrogen bonding is responsible for high freezing point, high boiling point, high value of specific heat, high latent heat of fusion, and high latent heat of vaporization of water in comparison to H2S and H2SE. In gas phase, water exists as the discrete molecules. Due to the presence of two lone pairs, the geometry of the water gets distorted and acquires a bent geometry with the bond angle of 104.5 degree and OH bond length of 95.7 picometer. In the liquid phase, the large number of water molecules are associated together by the hydrogen bonds. The solid or the crystalline form of water is ice. At atmospheric pressure, ice crystallizes in the hexagonal form, but at very low temperature, it condenses to cubic form. Hard water is the one which does not produce leather and soap easily due to the presence of calcium and the magnesium salts in the form of their bicarbonates, chlorides, and sulfates. For example, seawater. Soft water is the one which is free from soluble salts of calcium and magnesium. It gives leather with the soap easily. Distilled water and rainwater are the example. Temporary hardness due to the presence of bicarbonates of calcium and magnesium. The calcium bicarbonates, magnesium bicarbonates can be easily removed by boiling or Clark's method. Permanent hardness. This type of hardness is due to the presence of chlorides and sulfates of calcium and magnesium dissolved in water that cannot be removed by simple boiling. Permanent hardness can be removed by treatment with the washing soda, Kalgan's method, ion exchange method, Synthetic resins method. On the industrial scale, hydrogen peroxide, that is H2O2, is prepared by the auto-oxidation of two ethyl anthraquinols. Hydrogen peroxide is non-linear, non-planar molecule and it has an open book-like structure. It is a strong oxidizing agent. It acts as an electron acceptor in acid as well as alkaline medium. Also, it acts as a reducing agent in both acidic and the alkaline medium towards the powerful oxidizing agents. Decomposition of H2O2 is catalyzed by the presence of sunlight, metal surfaces, glass, alkali, dust, etc. The storage of H2O2 is inappropriate containers away from sunlight is necessary. Dihydrogen as a fuel is also used because of its various advantages over the conventional fuels like petrol, diesel, oil, etc. Primary pollutants are those which are persisting in the environment in the form of it is produced. Example, carbon monoxide. Secondary pollutants are formed from primary pollutants by reaction or change. It is caused by gaseous or the solid pollutants such as natural fog, pollen grains, bacteria, volcanic eruption, dust, smoke, mist fumes, gases and vapors. SO3 is more harmful than SO2 because it combines with water to form H2SO4, which causes acid rain, which causes yellowing of Taj Mahal and other monuments. Carbon monoxide. It combines with Hb to form 300 more times stable carboxyhemoglobin, which reduces oxygen carrying capacity of blood and result in the giddiness, headache, decreased vision, cardiovascular malfunction, and asphyxia. Increased level of carbon dioxide is controlled by green plants during photosynthesis. It is a greenhouse gas and responsible for the global warming. It causes headache, nausea, and asphyxiation. CFCs 1,000 times more effective than CO2, used in the aerosols, jet fuels, refrigerants in AC and fridge, fire extinguishers. They are depleting the ozone layer. Acid rain has the pH less than 5.6. Oxides of sulfur, nitrogen and carbon are acidic in nature, which dissolve in water and causes acid rain. Photochemical smoke. It is also called the Los Angeles smoke or oxidizing smoke as it contains ozone, PAN and nitrogen oxides. It occurs in warm, dry and sunny climates. PAN causes reduced visibility, irritation of eyes and respiratory tract due to the excess of nitrogen oxide, which is brown in color. Photochemical smoke is brown colored. Ozone hole depletion in the concentration of ozone over the South Pole in Antarctica is called the ozone hole. Bad ozone is formed in the troposphere that harms the plants and the animals, while good ozone is formed in the stratosphere, which acts as the shield. UV rays can enter in Earth's atmosphere. It is harmful as can cause the skin cancer. The process in which nutrient-enriched water bodies support a dense plant population, which results in the depletion of oxygen level, hence killing animals' life, hence results in the loss of the biodiversity, is called eutrophication. Green chemistry is focused on processes and products that minimize the generation and the use of hazardous waste. It increases using of those reactions which do not produce the hazardous byproducts. UV radiation dissociates CFC to give chlorine free radical, which combines with the ozone to form chlorine monoxide radical, which combines with the atomic oxygen to form the more chlorine free radicals. Classical smoke. It is also known as the London smoke or reducing smoke as it contains smoke, fog and SO2. It occurs in the cold humid climate. Hydrocarbons produced naturally as well as due to the incomplete combustions. These are carcinogenic and causes irritation of the mucous membrane, eyes. They cause aging, breakdown of tissues, shedding of flower, leaves and twigs in the plants. Those substances which degrade at very slow rate or does not degrade by the natural biological process, for example DDT, arsenic, salts of heavy metals, radioactive materials and plastic are the non-biodegradable pollutants. UV radiations dissociates SCFC to give chlorine-free radicals, which combines with the ozone to form chlorine monoxide radical, which combines with the atomic oxygen to form more chlorine-free radicals. Thank you.